Okay, next up, let's look at rotation matrices. To rotate the plane counterclockwise about the origin, an angle of theta, use this matrix here. And notice the determinant of this matrix is always going to be 1. And that makes sense because if you're rotating the plane, you're not changing the area of anything, and you're not changing anything's orientation. Also, if we take the determinant of this guy, it's going to be cosine times cosine, and then minus negative sine times sine. So you get this, which is identically equal to 1. So first up, let's play with this a little bit on the matrix visualizer thingy. So we've got this. Let's see if I can scroll that down a little bit. And this website, it actually has this built in. You can put in an angle, and it'll auto-populate the matrix for you. So there it is at 30 degrees. It's putting in the cosines and the sines there. Notice if I take this negative and get rid of it, it's no longer a rotation matrix. If I move the negative over to here, I believe, it makes it into a reflection. But anyway, if we just put in an angle, say 45 degrees, rotates the thing 45 degrees. All right, so let's do a problem. Find the rotation matrix for 30-degree counterclockwise turn and apply it to the triangle shown here. Round to 2 decimal places. Okay, so our matrix is going to have the cosine of 30 degrees in the up here and here, and cosine of 30 is root 3 over 2. Sine of 30 is 1/2. And this one is negative. All right, so let's use that to operate on these 3 points. Let's see, these points are, let's see, we've got 1, 1. The next point over here is 5, 1. And then the purple one up here is 1, 2, 3. It's 3, 3. So let's get the computer to do this calculation for us. I don't know why I keep calling that A. I'll call it T. So we've got a good question. How do we put this into octave? Let's see, if I just put in cosine of 30, it's dealing in radians. So probably the easiest thing to do would just be type these things in. I mean, we could convert them from 30 to pi over 6, but I'm just going to type in the numbers. I mean, 1/2 is easy enough, and root 3 over 2 isn't that bad. So we're 3 over 2 minus 0.5, 0.5 square root 3 over 2, and it gives me this. All right, so that's our transformation matrix. Our other matrix, I'll just call it B, and I'll put those in. 1, 5, 3, 1, 1, 3. Now if I do T times B, it gives me this. So I'm going to copy that down to 2 decimal places. 0.37, 1.36, or 1.37, 3.83, 3.37, and then 1.0, well, that'll round to 1.10, and then 4.10. All right. So now let's plot those points. Let's see, each one of these boxes is 1. So that first point is going to go to about 1/3, then 1 1/3. So that's close enough. Then 3.8 and 3.4. 1, 2, 3.8, 1, 2, 3. So that's going to be here-ish. And then 1.1 and 4.1. So that's going to be about right there. Now I'm gonna connect the original thing with some lines. This was the original. And the image is this. And for each one of those points, they moved 30 degrees around the origin. So like here, if I were to draw in this angle, or this line and this line, that would be our 30-degree angle there. All right. Again, if you're not interested in programming at all, you don't need to watch the rest of this, but I do want to play around a little bit with some P5.js stuff. I sort of jumped into this earlier. P5.js, it's a JavaScript library. So let's play around with this one. I've got, this is, what's the name of this sketch? This one is, yeah, rotation. And it's in here, and you can, I'm going to click auto refresh so that it'll automatically change as I put things in here. Let's see, I've still got a 400 by 400 canvas. Now, frame rate equals 30. That means this is going to do an animation. So up here, I've got all this stuff that applies the same stuff as before. And now, the apply matrix I've got down here, I put in cosine, sine, sine, and cosine there. Notice this one sine is negative. And I've got an angle of 45 there. If I put in an angle of 0, then it's just that square over there. And if I change this, it'll start to rotate it. Now, a cool thing you can do with this is, up here, I've got t equals 10 times pi over 180, so 10 degrees. You can put in t equals frame count. And since this is set at 30 frames per second, this should give me a, maybe frame count doesn't need this. Yeah, there we go. So just frame count, and it's flying around. So let's slow it down a little bit. Frame count over 20. And so it's applying that to there, and we get this little animation. Now, if we wanted to, it's drawing this rectangle. It's 100 by 100, and it's starting it at the origin. If I wanted to, I could change this to say negative 100, negative 100. And nothing changed. I'm not sure why. There, now I'm starting it at 10, 10. All right, yeah, you can tell there it's a sort of orbiting around the origin. So anyway, this is fun stuff you can play with. You can do certainly more interesting things to make a square spin around. But anyway, this is, I don't know, it's something to look at. All right, I think we'll stop this video here.